And one way we're going to do that, so we're going to try to understand why we can't get more than 63 here. So I'm going to start with a much simpler problem. What's the simplest version of this game that we could play?
1 square.
All right, where?
Just 1 square. It doesn't matter where. You can't move anyway. You just have one of these boxes.
Okay. Which one do you want to try to make it the simplest?
How about this one?
Why?
Because that's the one where you can't move anyway.
All right. So 1 square there. What's that worth?
That's just 1.
1. And are we sure?
Yes.
Yep.
Yeah. This is the one we're absolutely totally sure of. That this box, 1 in this box is worth 1. Okay.
Yeah.
What do you think the next easiest one to understand is?
Add 1 here.
Just 1 here.
Yeah.
Okay. Can you tell me what this one's worth?
Oh, this one, you erase it, and you fill 2 over here.
Okay.
So that would be worth. This one here is worth 2.
Alright, so this box seems to be worth 2. And are we sure about that?
Yeah.
Yeah.
Could that be worth more than 2?
No, because you can only move it once.
Alright, so you only have 1 move that you can do. Alright, what's the next case?
Yeah,
Well,
this one.
This
here.
one here, and you move it, you double it. So this is worth 4.
Interesting.
We know that because it can only move this way.
Uh-huh.
And there's only 2 moves for it.
Alright.
And the next one over here. So 1, 2, 4. This one would be worth 8.
It seems like this is going to be worth
I'm
8.
seeing the powers of 2.
16.
You're seeing the powers of 2. Why do the powers of 2 seem to be?
Well,
Because
coming?
you're multiplying by 2 every time you jump.
double it every time you move to the right.
So we think this is going to be worth 16, and we think this is going to be worth 32.
Yep.
Alright. Interesting.
And
Well,
what
wait.
does the sum do?
But if you add all them up, you get 63.
Hmm.
Because if you add all the previous powers up, it's 1 away from the next power, which is 64.
Ah, interesting. So it looks like the way we could understand the value that we started with is just breaking it into little pieces and adding them up. Have you ever seen this sort of pattern in math anywhere before?
Casework, counting?
Well, casework counting actually does work like this. You're right.
But the powers of 2
Yeah.
pattern?
Yeah.
Oh.
Binary.
Whoa.
We have the boxes, which might stand for digits.
It does look a lot like binary, doesn't it?
Yeah.
This box looks like
The
when we had 1 in there, 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 1 in there. This looks like the binary number 1, 1, 1, 1, 1,
So it's
1.
just like a binary translator.
Yeah. So this game seems to translate, well, most of the time when you're talking about binary, you wouldn't want to have a number like this. This is what we had after our first move, right? We had 3 in this bucket.
Yeah.
Most of the time you wouldn't want to have a number like this in binary, but you could still think about numbers. Like, what would this number mean in binary? 3, 1, 1, 1.
Well, you have 3 16s, 1 8, 1 4, 1 2, and 1 1.
So yeah. So there's a very interesting connection between this game
binary.
and binary.
If you added 1 more box, the maximum would be 127.
Wow, yeah. See, once we understand that connection, now it starts looking like this game's very easy to understand. But when you look at it the exact right way.
Yeah.
Pretty cool, huh?
So the
Alright.
maximum is probably going to be 63.
Yeah. This helps us see that the maximum probably is going to be 63. We haven't proved it for sure, but now we can be fairly confident that we weren't just getting 63 by accident.
Yeah.
All right, cool. Good work, guys.